In this sketch I'm going to include the stepper.h file, which allows us to use the three built-in functions for controlling the stepper motor. We need to declare an int or a constant int stepper per revolutions, which equals 248 steps. This is how many steps it takes for the stepper motor to do one full revolution. Next in the code, you can see I define a number of different pins to be allocated, which are A5, A1, A2, A4 and A3. These are for the sensor pin and the 4 LEDs used. And I also then define 4 blink delays, flashing LED of various values. I also declare a number of different int values. These could have really been constant int if need be, because they're not going to change in the code. And these are for different, so I have 3 speeds that the lift can go in, which are 3, 5 and 13. Then I have a number of different values for the amount of steps it's going to take for this whole sketch. Some are anti-clockwise, some are clockwise. Here you then can see I'm declaring stepper my stepper equals, and this is where we use the library stepper.h. We have to tell it the number of revolutions it takes for the motor, in this case 2048, and the stepper is connected on pins 8, 10, 9 and 11. In this sketch we basically have very little in the void setup. We basically declare pin modes for 5 items. The first being the sensor 1 pin. This gets the input pull-up, which calls for the internal pull-up resistor on that pin, which holds the pin high, so at 5 volts. I then also declare the pin modes for 4 of the LEDs as outputs. Also in this sketch I use 8 different functions for various things. So the first one is void light on, and this basically digitally writes the LED pins to high. The next function is void light off, and this turns all the LED pins to off using the digital write function. The next function is void flash, and this will flash the 4 LEDs on and off for 1 second, again using digital write. Here you can see I've got the delay, flash, delay. The next function is void down flash. In the video at the end of the display you'll see I set a sequence of LEDs flashing from the top all the way down, and this function creates that effect for me. Very simple, not a lot to explain in it. The next function does the opposite, and it flashes from to make the lift as if it's going upwards. Again, not a lot to it, so not a lot to explain. This function, void stepper off, I use so once the lift has travelled all the way to the top and all the way to the bottom, this will get called to turn the stepper motor off, stopping the stepper motor from overheating and possibly damaging itself. This function, void lift down, you can see we use the different values for the speed. So we set the speed in the first case, speed A, then we move the stepper motor to step E, then it will go to the next one, which is speed B, and it will move a number of steps, whatever is set in H, and so on. At the end of it we get a delay, in this case called flash delay, which will have a certain value to it. The next thing we have is void lift up, and this is the opposite way before. You can see I do mention here there is a maximum value of 15. This is what the motor manufacturers say. I've found it to be more like 13. The void loop in this sketch is very simple. It starts off with it's waiting for the sensor pin to go low, so i.e. a button press or a sensor press. Once that's happened, it will start then to work through each one of these functions one at a time. So the first function it calls is light on. So previous in the sketch you saw what that will do. Once it completes that function, it comes down. It then uses the delay function, and the time is set here as blink delay, which if I half a second, then it will turn the light to the next function to the light on, and so on all the way down through. When it gets to this one, this is the long delay, which lasts for approximately 1 minute. Then it will start again to send the lift all the way back down. And that is all there is to this sketch. There'll be a short video now after for you to watch the lift actually working.